Okay, good morning. Before starting today's lesson, let me just mention that the exam on Wednesday, on Math 4, is mainly, I would say 99% focused on your skills in differentiation, yes? Because you know that we have different rules, I don't know, product rule, quotient rule, chain rule. So you get a lot of problems in the book, in the exam, just differentiate, yes? So I just want to make sure that's the main theme of that exam. Okay, so let me, before, if you remember, we started talking about the factorial notation. I want to start the next topic of the lesson, but let us refresh a little bit by doing some exercises on the factorial notation, and then we just move on, okay? So let me give you this example and wait a little bit for you. So example, simplify this expression n plus 2 factorial plus n squared n minus 1 factorial, and then divided by n squared plus 4n plus 4. Another example I will write, you can start working on this. Yeah, the people at home, please take notes, because when I pause recording, you will not be able to see this. Okay, so I will wait a little bit for the people at home, and then I will pause the recording. About this one, I'm not sure, because what I have written here, instead of this, I have written 2 here. I don't know which one is suitable. Yeah, we will see. So you can also tell me which one is better. Because for one, probably you can simplify more if I choose the other one. I was thinking that if I put 4 here, you can write it n plus 2 to the 2, and might be can be simplified. But who knows, might be 2 is better. I don't know. Might be that's just a misprinting. Okay, now I pause recording the video. The people at home, did you actually write them down?
Yep.
Okay. Okay, so let us see how it goes. Which one do you think is the correct one, 2 or 4? 2 is correct. Okay, so let us write it. So it was not a misprint in my writing. I was thinking it might be, but that's good, thank you. So let me now try to solve them. So for the first example, what we want to do, for the denominator we cannot do anything right now, so let us keep it. But in the numerator, I want to try, because when you want to simplify a fraction, the goal is to factorize the numerator and the denominator so that the factors, common factors, can be cancelled out, yes? So if I want to do that, I want to factorize, but factorization probably is not that trivial. I need 2 numbers whose sum is 4 and the product is 2. Of course, there are some numbers, but they are not very friendly numbers. So let us keep it like this. But here, n plus 2 factorial, I want to do something to this bigger one so that I can pull something out. So I would use the property of the factorial. I will write n plus 2. I go to the previous number, which is n plus 1. I go to the previous number, which is n. And then I go to the previous number factorial. Why I should stop here? Because I see that I have n minus 1 factorial here. I can pull them out, yes? So that is probably the first starting point. Of course, you might have a different idea, but I will hear from you then. So then I will have n minus 1 factorial in both of them as a common factor. So I pull this out, and if you don't mind, let me write it the other way around. n plus 1, n plus 2 is left from the first term, and then plus n squared is left here, yes? And then I have n squared plus 4n plus 2 for the time being. I made a mistake. I could pull more, yes? sorry, there is also another n in common because n squared and n is also in common. So I pull another n out. Yes, that's correct. Yes? And then what I do, probably I have to n times n factorial, let us keep it. And then I expand this. N times n is n squared. And then 1 plus n times 2 is 2n plus another n is 3n. And then I have another n here, so it becomes 4n. Yes? And then 1 times 2 is just 2. So now we see that actually that one is correct. Yes? And then this one, totally, these two are gone. And then what is left is n times n minus 1 factorial. But I can write this in a more compact way as just simply n factorial. So simplified version of that expression is just n factorial. Yes? Any questions here? Okay. So what is your answer for the next one? You want to solve an equation. N is unknown. This is supposed to be 120. We have to choose n in a proper way. What was the value you got? Anyone get the answer for this? Might be it's a little bit hard because it becomes a third degree. By the way, it's a third degree polynomial, but n is an integer. So usually, yes?
4.
Let me see, 4. Yes, might be 4. Let us see. But I mean that let us see how it goes. If I want to solve that one, of course, the first part you try to simplify this expression. N plus 2 factorial, you can make it a smaller factorial by using that property. So I would write n plus 2. I go to the previous number, which is n plus 1. I go to the previous number, which is n. And then I go to the previous number factorial, which is this one. I don't need to go beyond that because n minus 1 factorial also appears in the denominator, yes? This is supposed to be 120. So then this becomes, let me write it the other way around, n times n plus 1 times n plus 2. So you are right. If you want to solve this problem in general, then you have to expand that and it becomes a third degree polynomial. And in principle, solving a third degree equation is not that simple unless you know how to factorize the whole expression. But remember here, this factorial symbol doesn't make sense at all if this number that is involved here is an integer, yes? Is not a natural number. So n minus 1, n plus 2, they should be natural numbers. Okay, so this means that, and then you see here I have the product of 3 consecutive natural numbers. Because this is n times the next number times the next number, and n is supposed to be a natural number. So then this motivates you to try to factorize this side in a way that you can match the pattern, yes? So then you want to write 120 as the product of 3 consecutive integers. Can we do that? So for example, this is 12 times 10. But I want to write it as a product of consecutive integers. What do you say?
4, 5, and 6.
Yeah, 4, 5, and 6. So I think, so this becomes 2 and 5, and this becomes 2 and 6, and then suddenly you see that these 2 and that 2 becomes 4, and then 4, 5, 6 appears. So anyway, any way that you can convince yourself, that is 4 times 5 times 6. And then if you compare them, as actually Martin mentioned, n is equal to 4. So this method is not correct if instead of n I have x, and x is a real number. But because I know that this is supposed to be an integer, this is possible to do it right now. Any questions regarding that? Understandable? Okay, now we go to these things. So these kinds of calculations, you should improve your skills. So for example, I give you these two fractions, I ask you to add these two fractions and show that this fraction is equal to that one. Because on the right hand side I have only one single fraction, it motivates me to combine the denominators. I want to have a common denominator. Of course, the common denominator can be the product of all these four numbers, but then you make the life harder for yourself. If you multiply all these things and put them as the common denominator, it definitely will work, but it is not that efficient. So this means that I need to find the lowest common denominator between these two. It means that I need to write a number which is divisible by this combination and this combination simultaneously, and in the meanwhile keep it in the lowest term. So can you tell me what is, so let me write from the left hand side, I start. I want to write a common denominator here. So what do you think I will choose for the common denominator? What is my best choice? What is the best choice? So for example, between 10 factorial and 9 factorial, 10 factorial is enough. Yes, because 10 factorial is divisible by 10 factorial, and definitely it is also divisible by 9 factorial because 10 factorial is 10 times 9 factorial. So I would write 10 factorial, but this will take care of those two terms, those two factors. And then between 20 factorial and 19 factorial, 20 factorial will do the job, yes? And now I ask myself, this divided by this, what is the result? So you can go to a scratch paper, you have 10 factorial, 20 factorial, which is your common denominator, and you can divide it by that. So what is the answer? The answer is 10. Do you agree? So this 20 factorial and 20 factorial are gone, and then this becomes 10 times 9 factorial, so it becomes 10 times. So that 10 times I have to multiply it here. So this becomes 10 times 29 factorial. And then I have plus. I do the same thing here. I do this division in my head by that one. So 10 factorial, 20 factorial divided by this 10 factorial, 19 factorial. And this time it becomes how much? 20. And then I have to multiply 20 here. Okay, but then how can I continue? The denominator is actually the same thing, and I don't need to change it at all because exactly that is the denominator that appears here. But I have 10 of this number, whatever this number is. I have 20 of the same number added to that. So in total I have 30 times 29 factorial. Is that understandable? Yes. And then 30 times 29 factorial has a better name. What is the name? It is just nothing except 30 factorials, 10 factorial, 20 factorial. And that is exactly equal to the right hand side. Yes? Is that okay? Now the last one. So what is the last one? I want to prove an identity including factorials, but of course for understanding reasons n should be greater than or equal to 2, otherwise this doesn't make sense. Of course n should also be a natural number. Okay, I don't know how we can do that because we want to prove an identity. It is always better to start from one side to reach to the other side. I don't know which one we prefer. So let us start from the left-hand side. You might have a different opinion, of course. Left-hand side. In the numerator, I cannot do anything. But what can I do for the denominator? So I have the sum of 3 terms. If I want to try to factorize them somehow, it is better for instead of n factorial, I can write n times the previous number times the previous number factorial. And I think you agree with me, it's a good point to stop there. And for n minus 1 factorial, I can use the same trick, yes? I can write plus n minus 1 multiplied by the previous number factorial. And I hope that you agree with me, we don't need to change anything at all for the third term. What was the goal? The goal is that to make a common factor so that I can pull it out and hope for the best. Yes, let us see how it goes. So then I will have n. I have n minus 2 factorial. I pull it out. From this one, n times n minus 1 is left. From this one, only n minus 1 is left. And from the last one, 1 is left. Yes? And let me simplify that. N minus 2 factorial. And then I multiply this n squared. And then I multiply this minus n. This minus n will cancel that n. And this minus 1 will cancel that 1. So this means that I don't need any pairs of brackets actually. Any questions here? Yes, understandable? And now I can simplify that. So what can I do? I can write it 1 over n times n minus 2 factorial. But might be we have some problems now, yes? Because that is not exactly what we have on the right hand side. One thing we can do probably is to put it here and try to simplify the right hand side as well. And then at the end confirm that what I got for the left hand side matches what I got for the right hand side, if it is possible. This is one way. But do you have any better idea if you want to? So let me, first of all, you really don't need to avoid this method, especially in the exam when you need time. So let me just tell you that, let us see what happens. So let me call this one number 1, and then go to number 2, the right hand side. So let me manipulate a little bit the right hand side as well. And then I have 1 over n minus 1 factorial, and then I have minus 1 over n factorial. Okay, so what is the common denominator between them if I want to have the common denominator? The motivation behind having the common denominator is that I want to compare the right-hand side with what I got here, and on the right-hand side of this expression I have one fraction. So it motivates me to combine these two fractions into one single fraction. So therefore, for doing that, I need to have the common denominator. Between these two, what is the common denominator? N factorial, yes? So n factorial, can you divide it in your head? N factorial in your head divided by this how many times? N times. And n I have to multiply here, so it becomes n. Minus what I have here, this is n factorial divided by n factorial 1 times here is 1. Okay, still it's not exactly like that. But then it is clear what to do. Instead of this n factorial, what can I write? I can write n times the previous number times the previous number. This time I stop here by putting the factorial, and then what I have in the numerator is n minus 1. This n minus 1 and that n minus 1 are gone, so this becomes n divided by n times n minus 2 factorial. You can put it number 2 here. Yes? And then if you compare number 1 and number 2, you can conclude that the left-hand side is indeed equal to the right-hand side. Yes? Of course, now that we did it in this way, we can do this part in the scratch paper. If you really want to go from one side to the other side, then it becomes clear what to do, which was not that clear. I need to rescale this fraction by n minus 1, and then I can just decompose it, and I will reach this side. But it reveals itself after we did it this way. But you really don't need to compensate for this thing, so that's completely okay. I simplified the right-hand side to one expression. I simplified the left-hand side also to the same expression. Two expressions are equal to the same thing. It means that they are also equal themselves. Okay. Any questions?
Wait.
Yes?
I was wondering on the first example, when you expand the first bracket, why did you put n minus 1 explanation?
Here?
Yeah.
So here, this is the question. I wanted to go to the, because you know that if you want to simplify a fraction, you need to try to factorize the denominator and the numerator so that you can have some hope for some common factors that they are going to be cancelled. Yes? Yeah, because I didn't, because if I want to factorize this, the numbers will be involved, square roots, things like that. So I didn't do anything with that. I keep it like that. But then I want to factorize. Here, here, and here, I do not have any common factors. So I cannot pull something out unless I produce it myself. Yes? So this motivated me to write n plus 2 factorial into this form up to here. Do you have questions up to this point or not?
No.
Because this, I can start from n plus 2 and I can write n plus 1 factorial. If I stop here, it's not enough because still I don't have the common factor. So it motivated me to continue until some common factor appears. Yes, so because you know that if you have 9 factorial, for example, you can write it as 9 times 8 factorial if you want. But if that is not enough for that problem, you can write 9 times 8 but multiplied by 7 factorial. If that is not enough, you can just continue this process.
So like the minus.
So you see, I started from n plus 2. I subtract 1 unit from this one to go to the previous number. If n plus 2 is your number, the previous one is n plus 1. But if I stop here and write n plus 2, n plus 1 factorial, it is not wrong, but it is not useful for this problem. So this motivated me to continue one step more. The previous number to that is n, but if I start writing factorial here, this is not useful. Then it motivated me to go one more step. Now here it is good, because at least you see n and n are in common, n minus factorial, 1 factorial and n minus 1 factorial are also in common, so I can pull it out. Yes, that was my motivation. I couldn't foresee what will happen next. My motivation is to make something common so that I can pull it out. And then the rest of the problem actually worked out. Yes. Is that clear? Okay, now let us go to this new lesson under the topic Combinatorics, under the topic of permutations. Okay, so permutation in Combinatorics has a specific meaning. I want you to understand that. Okay, so if you have some objects, okay, some objects, these objects might be distinct or not, but you want to arrange them in a row. By the word arrange here means that in a way that for some reason the order is important. So you have some objects. Let me just start with some 3 letters. For example, I give you 3 letters, A, B, and C. I ask you, so here you see A, B, and C are distinct objects. But later we can also relax this this condition. But I have 3 distinct objects, and I want to arrange them in a way that order matters for me. And I want to see, each one of these items is called a permutation. For example, let me just forget about commas to make it more precise, shorter. So ABC is a permutation of these 3 objects. So in this case, it really matters. A occupies the first position, B occupies the second position, and C occupies the third. Okay? So it means that when I write A here, but C here and B here, this should be counted differently as the previous one. The reason is that even though it contains the same letters, the same objects, A occupies the first position as before, but this time C occupies the second, B occupies the third. So you will say that this is one permutation of these objects. This is a new permutation, not the same. That is what I mean. Okay, if you want to write all the permutations, what can you write? How many of them are there, do you think? If you really want, what? No, 6. Yes? Because you could start with A. This time you can start with B, and then you have A and C left for you. But then, of course, you can write C and A. and then I can start with a C, and then I have A and B, C, B, and A. So if I ask you to write all the permutations of these three objects down, this is what I mean. Of course, in principle, you can put a comma between them, but that's understandable. So there are exactly 6 permutations of these 3 distinct objects. Yes? But now, I can also imagine this situation. I give you only 2 letters of A and 1 B. And I ask you to write all the permutations. That is also doable. Yes? So, but this time you have to be careful. These 2 A's, by convention, when I write the same letter, the same number, whatever, I mean they are identical. Okay? So then in that case, if I ask you to write all the permutations, what do you write? You write A, and then you can write AB. Okay? But you do not interchange these 2 because it will generate the same item. Okay? So this, I start with an A, then this is the only option available if I want to start with an A. And it doesn't matter if this is the A that I am starting with or that is the A. There's no, they are identical. These are conventions, okay? But I can also start with a B. Oh, sorry. I have also another option, sorry. I can start with an A, but I can interchange these 2. So this is recognizable from this. Even though A and A are identical, B and B are identical, but everyone can differentiate between this item and that item. So it means that they have to be counted 2 times, not once. Yes, because they are recognizable from each other. And then I start with the B. If I start with the B, how many of them I have? Only A, only 1. Because there are 2 A's left for me, and that's the only one that I can write. So, if I ask you how many permutations are there for these 3 items, one way is to write all of them down and count them, and then you say 6. If I ask you how many permutations are there, you can, one way is of course to write them down and count them. And of course, because now you have enough experience of what the word of combinatorics mean, we want to find a formula or a method to be able to count the number of permutations without writing them down. Okay? That is the goal of this. But I think this one is very, very simple. You can find a rule for it. So what is the rule? So can you tell me, if I have given you 4 letters, distinct letters for the time being, and I ask you the question, in how many ways I can, so how many permutations are there? One way to phrase it is exactly abstractly like I mentioned. How many permutations are there? Or I can say that I have 4 distinct objects, and both of them are very important to understand. You should imagine you have 4 boxes labeled 1, 2, 3, and 4. And what is the goal? The goal is to fill up each one of these boxes with exactly one of these items. So that is the way that you also should think. So in how many ways I can put these objects into these labeled boxes so that each box contains exactly one of these objects. This is an alternative way of planning the same problem. Yes? In general, it is n factorial. Yes? So here, it will be 4 factorials. So here, the reason it was actually 6, because 3 factorial is 1 times 2 times 3, which is 6. But why this is the case? Why do you think the number of permutations of these 3 objects should be 4 factorial? And then I want you to memorize it, or you can use it as a theorem. You don't need to explain it all the time. As soon as you realize your situation of counting is putting 4 distinct objects in 4 distinct positions, it means that you can immediately say the answer is whatever the number is factorial. Yes?
So the way I figured it out, so for A, you can put 4 different options.
Yes?
And then after A, you have B, C, D. That's it.
Exactly. You can see it 2 different ways. You can say that I want to fill up, that this is a 4-stage task for me. Yes? I want to fill up the first box. How many options are available? 4. Yes? There are 4 options available for this one. I put one of these letters inside the box, the first box, and then I go to second box. So how many options now is available for the second box? 3. Is this 3 independent of which one of these letters I have put here?
Yes.
Yes. So that's always 3. And then this stage is now done, and then I go to this one. What is this? 2. Is this 2 independent of the letters that I have put in these 2? Yes. And what will be left for me? 1. And then I have to multiply. Yes? Is that understandable that you have to multiply?
Yes.
Because if you stop here, your task is not accomplished. Your task is accomplished if you have done all these stages consecutively. Yes? So then it means that you stop here. This is one way to understand the problem, which becomes 4 factorial. You can also see it a different way. I told you that in mathematics, boxes and letters are both objects. So you can say that, okay, now I want to assign a box to A. In how many ways I can assign a box to A? 4 boxes available. So I put for A, I have 4 boxes, but I assign one of them here. What is left? 3. What is left? 2. What's left? 1. So in each perspective, the answer would be 4 factorial. So I want you to remember this. If I have n distinct, this is very important, objects, n distinct positions. Whenever the situation that you are confronting is this situation, that you have n distinct objects, whatever they are, and you are supposed to arrange them in n distinct positions, order matters. Then the answer is how much? N factorial. Yes? Is that understandable? So these things, it's very important. So you need to remember whenever you want to do this. For example, in how many ways 7 people can stand in a queue line? Okay, how should I look at the problem? 7 people completely, even they are they are distinct objects. Yes? So 7 people are 7 distinct objects. And of course, the word queue, we know that it means that order matters. Yes? So it means that I have 7 distinct locations to stand up and 7 objects. So you really don't need to explain. So I want you to understand. The answer to this is how much? 7 factorial and stop. Unless I ask you to calculate the exact number. Otherwise you just write 7 factorial, finished. Okay? Is that clear?
Yes.
Okay. Now let me ask you some questions to see how you answer these questions. Let me find. Okay, for example, if I give you the word, by the way, this is also a convention. I give you the word table, and I ask you how many words I can make up using the letters in this word. Okay, but be careful, this is a convention. So when I write table, you are only allowed to use T once. Yes? And it doesn't matter if it is pronounceable, meaningful or not. That is the convention we use. Yes? So here, when I ask you how many words I can actually make using the letters in the word table, it means that you have exactly 1 T, 1 A, 1 B, 1 L, and 1 E, and you want to arrange them. But of course you know that if you interchange the letters in a word, it matters, because it might produce another word. Yes? Meaningful or meaningless, that doesn't matter here. So this means that how many objects you see in front of you? 5. Are these objects all distinct?
Yes.
Yes. And then you know the order matters, and you want to fill 4 positions. How many positions? 5 positions.
5.
So the answer to this is just
5
5 factorial. For example, yes?
Or that's for 5 letter words.
Yes. Yeah. But now I ask you, how many of them start with a T? For example, I don't know, we can ask different questions. So how many words I can make up? 120, 5 factorial. Yes? But then how many of these words, how many of these 120 words that you have made is starting with a T? So what's the answer? 4, no.
40.
No, 4. Why do you say 4? 4 factorial, you mean?
Yes.
It should be 4, yes? 4 factorial. Because if I say start with a T, what do? You put T here and relax, yes? Forget about T now. And then you need to fill up the next positions with A, B, L, and E. So how many letters are left for you? 4. How many positions you want to occupy? 4. So it is 4 factorial. Is that understandable? How many of them start with a T and ends with an E? How many of them? Yes. 3 factorial. Yes? Because you fill up the first position with E, the T is gone. You fill up the last position with E, E is gone. How many objects are left for you, A, B, and L? You want to arrange them in how many positions? In 3 positions. So it is 3 factorial. Yes? Okay. Now let me ask you another question. So we have 5 boys and 7 girls, okay? Let me ask you this question. In how many ways we can arrange them in a row? And I tell you that. So let us say in this way. In how many ways these people can stand in a queue?
In a queue?
Yes, alternatingly. I hope that this is an English correct word. Alternatingly. In Persian, we have a very nice way of expressing these things, but I couldn't find the appropriate. So how do you say it in Swedish? I don't know. So we have, so for example, alternatingly means boy, girl, I mean this. Yes? Yes. But in Persian, we also have something, we can say have 2B, 2G. I don't know how do you say it in English. I don't know. How do you say it in Swedish? I don't know. Do you have any word? But in Persian, we have it. Okay, so that is a very easy way to talk about these things. But anyway, by alternatingly I mean in how many ways these boys and girls can stand in a queue. By this word queue, it means that I am referring that assume that the order is important. Yes? In how many ways they can stand in a queue alternatingly? What's the answer? 2 seconds. Yes? Yes? No? In how many ways? 5 seconds, okay.
It can start with, but it can start with boys.
It's 0, yes?
Yeah.
It's not possible.
It's not possible.
Because we have 2, because if you want to arrange them alternatingly, either the numbers should be exactly the same,
Yes.
or they can differ, but at most how much? By 1. So if this is 5, and so do you agree that this is not possible, yes? I don't know, if I start with a B, then I will have more girls than they will be next to each other. So this is not correct. If I ask you this, the answer is of course 0. But let me be a little bit wiser and ask you 6 girls. This is doable, yes? So I am asking you, in how many ways 5 boys and 6 girls can stand in a queue? By queue, I am referring that the order matters, but alternatingly. Yes, Kevin?
One way that you gotta start with the girl.
This is not one way. We have to start with the girl. Otherwise, we don't have that way. Yes? So we have to start with the girl. How many locations do I need for putting them in a queue? 11 positions. Yes? I need 11 positions. 1. Because I have how many people? 11 people. So definitely I need 11 locations. You can imagine it in this way. So you have 11 distinct positions. You want to fill up these positions with 11 objects. All the objects are distinct because they are human beings. And then I want to have a constraint. But can you tell me which one of these sexes should actually occupy the first position? Yes? Which one?
Girl.
A girl.
Yes.
So if I give this one to a girl, then if I want to respect the constraint, number 1, number 3, number 5, the odd positions should be given to girls, and then the even positions are left for the boys. Okay, but this task you can imagine, be careful again, because otherwise it becomes soon confusing. So I can assume that this is a 2-stage task for me. What I do, I first locate the girls in odd positions, so I can say that stage number 1, locating the girls in odd positions. Okay, now can you tell me how many ways I can do this first stage? Again, imagine this picture. You have how many objects? 6 girls. And then you have how many positions? 6 exactly. So this becomes how much? 6 factorial. And then stage number 2, after stage 1 is done. What is the meaning? It means that the girls are settled down in their locations, and now I can go and ask boys to be located. So you can just write it yourself, locating the boys in even positions. Yes? Okay, how many objects now I have? I have 5 objects. How many distinct positions? 5. But the whole task is accomplished after these stages are done. And this 5 factorial, by the way, I want to make sure that this is independent of the number that I have put here. When I want to write this factorial, I don't care which girl is occupying these positions in which order. Whatever they have done, I can still write 5 factorial. This is exactly important. So it means that the total answer to this question is 6 factorial times 5 factorial. Yes, and that is enough for the exam, unless I ask you to calculate it using your calculator. So this 6 factorial times 5 factorial. Yes, questions?
Can you write this as 6 times 5 factorial and then parentheses to power 2?
Yes.
That's possible.
Yes.
Okay.
That is possible, but you are confusing me. Then I have to calculate why this is correct.
Because 6 factorial is 5 factorial.
Yes, of course, but you don't need to do that. Yes, unless you want to test me, because otherwise, of course, this is 6 times 5 factorial to power 2. But I prefer to keep it in this way, because by just looking at this, not only I see the answer, I can also somehow understand your methodology. But that, if you write it, that's correct. Okay, but now let me change the idea. So 5 and 7 didn't work. 5 and 6 worked, and that is the answer. And now let me write 5 and 5 this time. Okay, will it work or not? 5 boys and 5 girls, probably it works. But the number might be, you need to be a little bit more careful, yes? Because you also need to care about the sum rule, yes, here. You have 2 scenarios going on. You should say that either I start with a boy and go alternatingly. This is possible in this case. Or I can start with a girl and go alternatingly. This is also possible. But these 2 categories are completely different. If I start with a boy, the arrangement is totally different from the one that I start with a girl. So it means that there are 2 scenarios that I have to count. Yes? Now, without actually wasting a lot of time, can you just tell me, I can decompose the problem into 2 parts. Start with a boy, or, so usually I told you these phrases, or usually means addition rule, sum rule, and means multiplication. Yes? Start with a girl. Okay? So can you tell me how many ways I can do that? Because this is more or less everything on the board. I start with a boy. So it means that so you, instead of having 11, I have 10 positions right now. if I start with a boy, I have to give the odd locations to boys.
Yes.
So how many ways I can do that? 5 factorials. And then even positions are left for me that I have to dedicate them to girls. In how many ways I can do that? Yes? In how many ways? So let me write it. 5 factorial. Yes, I have 5 girls. I want to locate them in even locations. Even locations are 2, 4, 6, 8, and 10. 5 of them are there. 5 objects, 5 positions, this thing, all of them. So that's the answer. Or I start with a girl. How many ways I can do that? I have to dedicate odd numbers to girls. But still it becomes 5 factorial. Yes? And then I have to put the boys. That is the answer. But then of course this can be written more compactly as 2 times 5 factorial times 5 factorial. Yes? Yes? That is also clear now. Let me give you another example that's also a very simple but a very nice example. And then this example, I call it important because you can use this idea in different type of problems. So here, let me ask you this question. So assume that you have 3. So let me write more numbers. I have 7 chemistry books. So let me see chemistry. All of them are distinct. And then you have, for example, 9 math books. All of them are distinct. And then you have 12 physics books. All of them are distinct. Yes? So, I mean that they are not the same book. Even if they are mathematics, either they are different topics. Anyway, you can recognize the difference. Let me ask you some questions. In how many ways, if I don't care about the order, I care about the order, but I don't need to be organized. In how many ways I can arrange them in a bookshelf, a long bookshelf? In how many ways? 28, yes? You want to add them, yes? So 7 and 9 is 16. 16 and 12 is 28. So it means that I have 28 objects and I want to arrange them in a shelf, and I ask you to answer this question so that order matters. So if I don't have any constraints, it becomes 28 factorial. Yes? So I want to arrange these books in a shelf, in a long shelf, and I tell you that I am interested, I want to take order into account for some reason. Okay? So this is the way that we can arrange them. But of course, that's a mess up usually. If you want to arrange a library, you prefer to put the books of the same topic next to each other. Yes? And now let us make it more organized way. In that case, in how many ways you can do that? So now the constraint. Without constraint, the answer is 28 factorial, which is a very huge number probably. But we just write it like that. But now I want to have chemistry books next to each other, mathematics books next to each other, and physics books next to each other, and I want to arrange them. But I don't care which chemistry books is coming first in the chemistry group. Yes, Kevin, do you want to say?
7 factorial plus 9 factorial plus 12 factorial.
Yes. Yes? Is that right? Yes or no? Now this is the first thing that this is wrong. There is a very serious thing wrong about it. So what Kevin mentioned is 7 factorial plus 9 factorial plus 12 factorial. No, forget about the details. There is something very serious mistake there. So can you fix it yourself?
I think so, because the categories can appear in different orders.
Yes?
So maybe you should multiply it by
3?
No,
perhaps
that is not a serious mistake. That you need to take that one into account. But it's more than that. It's a really serious mistake. Yes?
And you need to multiply it by 3 factorial.
No. We'll come to that later. More than that. It's really serious. Because if you remember when I started, I told you that you usually get confused when to use the sum rule and the product rule. This should be multiplication. So if this is the first time probably you see that you can get confused. You couldn't believe that you get confused when you want to. I know, of course, when to use addition and when I use multiplication. This is a serious mistake. First of all, I want you to understand why it cannot be addition.
Okay.
Because when the task is finished, you cannot say, because the task, this is why I tell you that you have to remember, just rephrase it in your own language to see what is the task. The task is not a one-stage task and finished. You can arrange the chemistry books and go, okay, say that the task is finished. No, the task is we have to put the chemistry books and the physics books and the math books. Yes, so that's a 3-stage task. And in that case, you cannot add. Yes? So this is very careful. Be careful. Now, what you said is now correct. It comes at, but that is a serious mistake. Okay, if I want to fix the problem, you can imagine what to do. Yes, what you can do, you can put the chemistry books in a box. Imagine that you put the chemistry books in a box, and then you label it with C. And then you can put math books in another box, and you can label it M. Imaginary box. You don't need to have that box. Yes, you can imagine. And then you can put the physics books in a box and label it with physics. And then now this is a new object. Books are books, but this is not a book. This is a box labeled C. This is a box labeled M, and this is a box labeled M. And then you see that when I move this box around, that constraint that I want is automatically satisfied. Because if I move the chemistry box here, all the chemistry books goes with it, yes? So then it means that how many so see, this is the way that you need to think. How many objects I have? So let me differentiate between these. I don't know. Let me, for example, put it a little bit careless. This is C. Yes, this is M. And this is, I don't know, P, for example. So I have 3 letters, this thing, I want to locate them. In how many ways I can locate them? 3 factorials, that's simple as that, yes? I have 3 objects, I want to arrange them in a row, yes? I can start with C and put M and P here, or I say that no, I want to prioritize physics over mathematics, I can change it, whatever. It is 3 factorials. But is the task finished? No, because I can still, in this box itself, I can reorder them.
Yes.
Yes, in how many ways I can reorder them? 7 factorial.
Yes.
In this box, 9 factorial. And in this box, 12 factorial. So what is this? What should I write here, here, and here?
Times.
Times, yes. That's the answer. So that is the way that you need to imagine. You can, I don't know, bundle them with some thread or something, or you can imagine them that you put them in a box. This will take care of that constraint that I want to have them in the same, next to each other. Okay. So this 7 factorial takes care of the number of permutations of the books in this box. This 9 factorial for this 12 factorial for this. But this 3 factorial that Kevin was trying to fix, and it was right, the problem was that you had these addition instead of these multiplications. But this is the correct answer. Is that understandable? Yes or no? But for example, let me ask you to try to see if you understand. If I only care about mathematics, and I don't care about the mess that I make with chemistry and physics, I want to have mathematics books only next to each other. In how many ways I can do that? Let me ask you this question. So here, my priority, for example, is with mathematics. Actually, I don't care about the order, the organization for these physics and chemistry. And I want to have only math books next to each other. It might happen, of course, chemistries are also next to each other, but I don't care. What I care is math books all next to each other. So in how many ways I can do it right now?
Det finns ju 2 positions som man kan ha.
Yes?
3 factorial times 9.
No. No, you have to have a strategy. You can defend your strategy, might be I'm wrong. But I have this constraint. I want to have math books next to each other, and I don't have any constraints. First of all, this number is bigger than the previous one or smaller? No, it should be, because whenever you have constraints, the numbers satisfying more constraints is lower. Is that understandable?
Yes.
So that's natural. So the number this time should be even larger than this number. Is that understandable? Because I have less constraints.
Yes.
That is for sure. So the number that you mentioned is probably much smaller than this number. That's one way to understand it. Yes, Dima, do you want to say something? Give me your strategy. I don't have it in my mind, but give me a strategy. I want, okay, what do you say?
So there is 9 factorial ways you can organize the math books.
Yes?
And then there is 9, the order for physics and chemistry doesn't matter. So you can organize it like first the math books comes, then all the other books, or and then those books.
No, we have to be very careful. You know, might be you are considering an item 2 times, or you are ignoring. You have to have a very nice strategy, very clear one. Yes?
You can group the chemistry and physics books, so 19 factorial.
Yes?
Times 9 factorial times 2 factorial.
No. Is it confusing or not? The idea was more or less correct, but you made it wrong at the end. By the way, could you read? Can you do it really? If I give you these many books and I say that order them in this way, can you do it or not? No, I mean in reality, forget about combinatorics. I give you 9 books, math books, and chemistry and physics books, and I say that, okay, when I go back to my lecture and come back, please arrange them in a way that math books are next to each other. Do you think you can cope with that or not? When you can cope with that, if you try to understand what is going on in your brain, you will be able to actually organize it. Yes? So, yes?
It's 9 factorial times 28 factorial times 19 again, because I can organize the box itself first, in the 9 factorial ways. Then after the box, there is 9 factorial ways. All of those books can be organized, and then I can place the box in between.
But how do you really know that this is taking care of all cases?
Because,
So you are making it a little bit harder. I understand your strategy. If I want to do it, as you said, I put math books in a box, okay? And then I call it this. And then chemistry books are C1, C2, up to C7. Yes, I can imagine like this. And physics books are P1, P2, up to P12. This is the situation that I have right now. Inside the box, I don't care how many objects you see in total. This is important. Be careful about this. This is coming from my experience. This is why I'm just after this problem I'm asking you this. So, how many objects you see? Yes? 20. Yes? You have a box in your hand, which is a big one, a big object, but you have other books in your hand as well. In total, how many objects you are facing? You are facing 12 here, 7 here, which is 19, but you have a strange object. It's not homogeneous, but it's an object. Yes? Now, if I ask you in how many ways you can arrange them, you can say that 19 factorials without any problems. And be careful. In these 19 factorials, what is happening? This whole box is moving around. Yes? So this is already taken care of, that math books are next to each other. Yes? But this is not the end of the story, because here I can also start ordering them. In how many ways I can order these math books? 9 factorial. So that is the correct answer. And then I hope that you are not confused to add or multiply. I really want you to understand you have to multiply. Because your task is accomplished if the arrangement is finished. The arrangement consists of 2 stages. Taking this box with me and these objects, moving them around, and after that is finished, I am settled down with the position of n. Then I can open the box inside it and start arranging them. Yes? No. 12. Ah, yes. Sorry. Thank you. Thank you for fixing this. 12 plus 7 is 19. I made a mistake. This is one more object. Thank you very much. That was a really big mistake if I couldn't catch it. Thank you. Yes. I was actually, everything that I told was again exactly aligned with this one. So I have one object and 19 objects here. In total, I have 20 objects. I put a 20 factorial here. This means that I am arranging these letters and this big box around. And then when I am settled down, then I go open the box and arrange the books inside. So that means that this is 20 factorials times 9 factorials. And this number is bigger than this number. If you drop this one, this means 3 factorial, 7 factorial, 12 factorial is larger than 20 factorial. And it's not hard to convince yourself even without calculator. Let me ask you one question. Now, because I actually studied mathematics and physics, so I don't care about chemistry, for example. Now I want to arrange math books next to each other. If you can answer that, it means you understood the problem. The constraint is math books next to each other, physics books next to each other. Don't care about chemistry. Then in how many ways you can do that? I give you a little bit of time. Write your number down, and please, I want you to digest what is going on. If you can write that number correct, means you understood the problem. Actually. The time is finished. Yes, but just this problem and we are done. Yeah, my watch is actually not working properly today. Okay, are you ready? So, we have math box, hopefully you understand, yes? And then we have the physics box. And then what should I add to this? 7 books of chemistry. Yes? Now if I ask, the goal is to arrange them. But I don't need to be very worried about putting physics next to each other because they are already in the box. If I start moving the box around, they will go together, definitely. So then can you tell me what should I write? The first one? Yes, Yomia? 9 factorials. Yes.
So it's 9.
Times another 9. Yes, but be careful. This 9 factorial is the number of items here we are arranging. This 12 factorial is the number of items here, but this 9 factorial is a coincidence here, because in total, how many objects you see? 9. So this 9 factorial is arranging these objects. This 9 factorial is arranging these items within this box. This is this, and this is the answer. Is that understandable? Thank you very much.